Now we see the fundamental theorem of calculus, which is used to calculate the definite integrals. Now it says that if integral of some function f of x is the function g of x plus c, which is the constant of integration, then the definite integral of f of x evaluated between the limits a and b is given by g of b minus g of a. So here what the theorem is saying is that to evaluate the definite integral of some function, we first calculate the indefinite integral by already known methods, and we substitute the upper limit into that integral, that is g of x, which is the actual integral function, and from that we subtract the expression obtained by putting the lower limit in the same function, that is g of x. So that is g of b minus g of a. Now we may wonder where that constant c has gone from the answer. So the reason behind that we are not able to see that c is that it is actually like this, that is this definite integral is evaluated between the limits a and b, and what it says is put the upper limit and from that subtract the expression when you put the lower limit. So when we put the upper limit in place of the variable x, we will get g of b plus c, right? From this we have to subtract the expression when we put x as a, so that is g of a plus c. So here we can easily find that the c gets cancelled out. So therefore we are left with simply g of b minus g of a. So therefore this is one very important point to be kept in mind, that in case of definite integrals there won't be any arbitrary constant of integration at the end, because that simply gets cancelled in the process. So now based on this theorem, let us calculate the definite integrals for some of the questions. Now here we have to evaluate the integral of x square minus 2x plus 1 between the limits 1 to 2. Now here, as we have seen, first of all we have to integrate the expression as if we are doing the indefinite integration. So we know that integral of x square is x cubed by 3 minus integral of 2x will be nothing but x square, because x square has the derivative as 2x, and lastly the integral of 1 is x, and this is to be evaluated between 1 to 2. So just to repeat, we are not required to write the constant of integration c, because anyways it is going to get cancelled. Alright. Now the way we calculate this is, in this expression first we put the upper limit, so that is we put x as 2, so that is 2 cube is 8 by 3 minus 2 square is 4 plus 2, right? And from this we subtract the expression when we put x as the lower limit, that is 1. So that gives us 1 by 3 minus 1 plus 1. So minus 1 plus 1 gets cancelled. So here we have 8 by 3 minus 4 plus 2 is minus 2, and we have minus 3. So we may club these two first, that is 8 by 3 minus 1 by 3 is 7 by 3 minus 2. So that is equal to 7 minus 6, which is 1 by 3. So that's the answer. So you see how simple this procedure is as compared to finding the definite integral as a limit of a sum, which is a more tedious process. Now let's see one more question. Now this is based on the trigonometric function. Now to evaluate cos square, we know that first we have to convert it into the trigonometric function of single degree, that is we don't want square or cube. So cos square x can be written as 1 plus cos 2x whole upon 2 integrated from pi by 6 to pi by 3. So that gives us, taking 1 by 2 common, or rather outside the integral. Now the integral of 1 is x, and integral of cos 2x will be sin 2x upon 2, because the coefficient of x is 2, and this integral is to be evaluated between pi by 6 to pi by 3. So that gives us 1 by 2. Now we have the upper limit substituted minus lower limit substituted. Now when we put x as pi by 3, we have pi by 3 plus, now sine of 2 into pi by 3, that is sine of 2 pi by 3. So just to recollect, how do we calculate? This is pi by 3, and 2 pi by 3 will be 180 degrees. So the sine of 2 pi by 3 is same as sine of pi by 3, which is root 3 by 2. So here we have therefore root 3 by 2 divided by 2, that is root 3 by 4. And after putting the lower limit, we have x as pi by 6 plus, now sine of 2 into pi by 6, which is sine of pi by 3, which is once again root 3 by 4 as in the previous case. So that gives us 1 by 2. Now if you observe, root 3 by 4 will get cancelled, and pi by 3 minus pi by 6, which is nothing but pi by 6. So therefore finally the answer is pi by 12. So that is the way we evaluate this limit using definite integrals.